button here, and now we're going to take a look at Pythagoras' theorem. And I say that, or is it, because the more you look into it, the more fascinating it is, and it's not really his at all. So, this is a right angle triangle, and I can't just make these numbers up. This is what we call a 3, 4, 5 triangle. It actually works. There's only a very few of these, and I'll talk a little bit more about it later down here, called Pythagorean Triples. But basically, this will help you understand it. So if you take the square of this side, you'd get an area of 9. And if you take a square of this side, you would get an area of 16. And if you took a square of this side, you would get an area of 25. And you should notice something very significant between these three numbers, which is these two smaller sides squared add together to make the larger side squared. Or if you wanted to find this one, you would do that, take away that, and vice versa. This take away this is that. So this is what they noted about the properties of a right angle triangle years ago, and they can't just use numbers. You have to use a formula to represent any right angle triangle in the world. So they called the smallest one A, and therefore A squared would be the area. They called the middle one B, and therefore B squared would be the area. And when you add those together, you get the larger one, which we called C, and the area of that is C squared. So this is the formula that is born from this understanding. So basically, to find the longer side squared, it's the two shorter sides squared and added. And you can set up the formula in other ways. So if you wanted to find A squared, to find this one, it's 25 take away 16. So it's the bigger one, C squared, take away the B squared. And again, you can do the same to find this one. It would be that, take away that, so it would be the bigger one, take away the other one. And these are the three formulae that would really help you to understand Pythagoras. So let's have a look at some questions. So here's two, and here I like to label them A, B and C, and I always go for the smallest one to be A, the next one to be B and C. So we're finding C, so I know the bigger one is the two other ones squared and added. Pop the numbers in now. So 4 squared plus 9 squared, 16 plus 81, and add these. So we have 97. So we have C squared to be 97. So basically, we're saying the area of this one was 25. You had to square root it, square rooted, square rooted. So the area of this square is 97. We have to square root it. Now, I'm not going to use my calculator, I'm just going to leave it like this. Sometimes they might say leave it in surd form, or if you just pick up your calculator and round it to whatever they ask you. So here, this is definitely the shortest just by looking at it, so I'm going to call that one A, this one B, and the longest, the hypotenuse, C. So we are now finding A. So I know the smaller one is not these two squared and added, because these two squared and added makes this one. So it must be the big one, take away the other one. So 11 squared, take away 7 squared. 121, take away 49. Let's pop the rest of my working in here. So what's that? 50, 70, 72. So therefore A is the square root of 72. And you could take that further using surds if you've watched that video and understood it, or you can just type that into your calculator and get an answer and round it to 2 decimal places, 3 significant figures, pretty much whatever they ask you to do. Now, essentially, all you're doing is, are you squaring and adding? So this is another way to think about it. If you're squaring and adding, that's because you're trying to find the longest. And if you're squaring and subtracting, it's because you're trying to find one of the others. Now, if you accidentally squared and added, you're going to get an answer that when you square root it is bigger than 11. And it can't be bigger than 11 because it's this. And if you accidentally subtracted these ones, you're going to get an answer smaller than 9. And this has to be bigger than 9. So it's another way of checking. Also, like I said at the start, there are certain Pythagorean triples like 3, 4 and 5. That works. If you multiply it by 2 or 3 or 4, you create other multiples of this one. So 6, 8, 10, very, very popular. It comes up an awful lot. So if you just remember those, you can save yourself a lot of time. Another popular one is 5, 12 and 13. 169, 144 and 25. These add together to make that one. So that's Pythagoras'